This meeting is being recorded.
Okay, can someone summarize me what we have discussed in the previous class, please?
I can do that for you. The last class we discussed was about wireless concepts and configuration. In that, we discussed about the frequency ranges for radio frequency, which was about 2.4 gigahertz and 5 gigahertz, and the band and standards, and in which year they were deployed, and the bands and the maximum speeds, and non-overlapping channels for 2.4 gigahertz and 5 gigahertz, and SSID, which is service set identifier, and pre-shade key. And at the last, we discussed about wired equipment privacy, which has passwords and pre-shade keys. And we discussed about WPA, WPA2, and WPA3 respectively.
Yeah, that's a good summary. Thank you. So we discussed about the various wireless standards and how wireless is being used in the network. We discussed about, what is the frequency and how do we deploy and where do we deploy 2.4 versus 5 gigahertz. We discussed about, managing multiple access points from a single controller in the corporate network. And we discussed about having an secure implementation of wireless in the network. We touched a little bit about .1x and also, security standards, like what are the before we touch the standards, we touched about non-overlapping channels. What are the range of channels that we have? And then we talked about securing that wireless inside the organization. So there are different standards, like Warren mentioned, WEP to WPA and various versions of WPA, and how can we secure it as much as we can. That's about the last class. Do you guys have any questions before we start the last section of the CCNA, which is automation and programmability? By this topic, we are done talking about the theory. We also did some labs. If you're someone who has been following this course from the beginning, we did some labs like switching lab, routing lab, we did router on a stick, trunking, like that kind of labs we did. But we left OSPF and EIGRP lab to the last part. But this will be the last section in the CCNA, automation programmability. Before we move on to that, do you guys have any questions from the previous class or last 3 classes? Okay, then let's start. So to give a base level idea of this topic, let's start talking about why do we need automation in the real time. Let's see. Anurag, Paul, can you tell me why do we need network automation? Do you have any idea on that?
Sir, since there are a lot of routers and there are huge number of systems that we have to send deployment to in a single time, it will be impossible for a network engineer to do that individually. So that is why we use automation tools. It can be used for troubleshooting and also with installation or pushing updates to the routers or systems.
Yeah, that is a good use case. When we have like a lot of systems, instead of manually configuring each one of them, we can do the bulk updates, we can do upgrades, and we can do configuration. Okay. Hari, any other thoughts? Why do we need automation?
Easier for troubleshooting.
Can you elaborate on that answer? Like how automation makes easy for troubleshooting?
It is easier to find any issues.
How? Like writing a code to find troubleshooting the issue? Like you write a code and it will be deployed, so it will be validating the end-to-end flow. Is that how you want to do that?
So if an router or system is down, it will show where exactly the error is, and it will pinpoint the errors.
Now we already discussed about a protocol for doing this, right? We don't need automation for this. Which protocol is that? Anyone? So if a router or switch go down, to pinpoint that, which protocol will be used? Anyone in the class?
So we used to use SCADA protocols. This is my first class. I mean, this is my second class, by the way. I think we use SCADA protocols as one of the network automation.
Sir, it is SNMP.
Yes, it is SNMP. So with the SNMP, we can identify there is a
SNMP,
problem
sir.
with the uptime. Yeah, SNMP, correct. Yes, SNMP is used for uptime. Make sure that if there is any alert, we discussed about various SNMP versions, right? But we talked about how SNMP sends a trap to the manager and how we can collect it and how we can send out and open a ticket with that, right? So SNMP is that to identify that. What else we can do with automation? I mean, we can do automation with pinpointing that by using like an netconf or a netcad. There are different protocols out there which can do that, but SNMP is way simpler, right? It doesn't need automation for that. Okay, Kanish, can you try any more use cases to do the automation? Okay, let's see. Rangachari, any thoughts?
Actually, I didn't get the question. You're asking about protocols or thoughts?
No, I was talking about any other ways we can use for automation in the networking. We have gone through some classes, right, from the beginning. Do you think using automation we can improve any process?
Yes, we can save some time.
Okay, yeah, that's a good use case. We can save some time because when we do the configuration manually, we can do it within like an hours. We can do with an automation. We can run the same script.
Yeah.
That will save some time. Yeah.
Instead of manually doing every time.
Okay. Yeah, that is also an advantage, but it is not a use case. Anything else, guys? Anything that we are missing?
Yeah, I think we can use it like not for manually doing the firewalls and everything. We can do it automatically.
Well,
So security provisioning.
Sorry. So when you mean a firewall, you meant to say like firewall policies. Instead of you manually creating them, you can use an automation tool to build firewall policies. Is that what you meant?
Yeah, using automation tools to build firewall policies and to create new to create new routes and everything.
Okay, you mean to say creation of new routes. We can
Yeah.
deploy that. Okay, yeah, I mean that is also a configuration thing. So
Yes.
so apart from configuration, apart from troubleshooting, Any other things that we can do with automation, guys, that you can think of? Of course, we can do upgrades, right? We can, instead of me manually upgrading the devices in a change window, we can run a script that will automatically runs on multiple devices at the same time. That will also save some time, and we can also upgrade bulk into one, at a time, right? That is one thing. What else? So we can, sorry?
Sir, from a security standpoint, it is better to use automation tools because it is easier to push security policies or ACLs, access control lists, and also whenever a security threat might come up, it is easier for an automated box to, send out, close that particular system or do the necessary steps to mitigate any type of risk.
I agree, but it is also a configuration path, right? So we are still changing the configuration. Instead of doing manually, we are using the automation. So that is a use case. Apart from the configuration, do you guys think of anything else that we can do? Is my question.
Efficient management of network inventory. Like we can use different. Yes.
Instead of we manually putting the serial numbers in a place, instead of we identifying how many switches we have, how many routers we have, we can run a script that will try to do a scan, or that will try to run across the network, and then it will give us updates on which switch is responding back to us. So we can efficiently manage all of the network from a single management use case or from a single automation script. We can do that. Yes, that is one of the use cases.
Troubleshooting the networks.
Yeah, we talked about troubleshooting, right? We talked about, like, let's say, you want to check the trace out from multiple places in a single go. You can run the script, it will log into the device, and then it will run the trace route, show IP route commands for you, instead of you manually doing in different places of the network. Yeah, it helps you in troubleshooting. It helps you in identifying the problem more quicker than you doing manually. Yeah, so troubleshooting is also a good use case. Yes.
And like we can avoid some errors.
Okay, yeah, manual errors can be avoided. For example, a manual person, if a user did a typo, it might cause an issue to the network, but the script that you're running will never do wrong a typo, because it is a automated process. So whatever script we are running, that will be executed from the rotated script. But if you did something typo in the script itself, then it will cause more outages than you believe, right? So before we deploying, we have to make sure that there are no errors in the script, and then you can deploy that. That way, it will be, when it pushed, it can be pushed to multiple devices, and it will not do any errors in the real time. But your script should be good, right? Yeah. So the typos, yeah, and what else? Anything else?
We can reduce the resources, like human resources. With
Of course.
automation.
Yeah. Instead of having 2 people, 3 people in the team.
Yeah.
If you have a good workflow, if you have a good automation work that is built, that can reduce the resources that's are needed for the project, right? An automated script can do your job, then why do they need to pay you like $1,100 an hour, right? If the script can do your job, right? So it's easy to manage the networks with automation. It will reduce the man hours, and also it will reduce the number of people needed in the team, right? Okay.
Ongoing maintenance will be also be easy if we automate all the networks.
Yeah, that also comes with the change windows, right? When you're doing changes, if you do it automation, the maintenance will be easy, because you just pull a switch. I mean, you just pull a script that will automatically deploy to multiple places. So that way, it all interconnected, right? It will reduce the time, it will reduce the number of people, it will reduce the man hours. So yeah, everything will be there. Yes.
Maybe we can analyze the network continuously for any upcoming security threats or something.
Yeah, I mean, we can forecast the network. There are other tools that are out there, the scanning tools, pen test tools. There are other tools that are out there that can help us in identifying more threats with automation. But it's not the CCNA level of automation that we talk here, right? We are someone who focuses on network automation than the security automation here. But yes, it is a good use case that you told that, you know, we can forecast the problems, make sure that we are, you know, following all the mitigation techniques, and we are well aware of all the updates, patches that are available on the network, and we can push them across the network. But as a network engineer, you don't do that. It is the responsibility of a security engineer or security administrator or SOC team, security operations center team. So there are different teams who will really work on that. You as a network engineer, don't do that. If you are a network security engineer, you can share some responsibilities, but still maintaining, auditing, making sure your systems are secure is part of the security operations center team role, not a network engineer role. But we will help them to make sure that we do the patches, we do the upgrades as per the suggestion to us. Okay, I think you guys did a good job. We pretty much covered what we wanted to cover in this specific section. This is nothing but impact of automation on the networking. As we discussed, it is a streamlined process. It will enable an administrator to automate like repetitive tasks. It can do like automate the network configuration. It can do the automation of software updates. It can make sure that it will save some time for individual tasks, and we can reuse the time to other important stuff in the network, right? So if there is an tedious tasks are overwhelming, that you are doing the same thing again and again, we can automate that and we can save some time and we can reuse the time in elsewhere. So to help in the streamlined process, right? You can also do like accuracy improvement. So we discussed this point as well. When you automate a particular task, it will be performed, which will be having less errors, less human errors. When an automated software does it, it will make it faster. So it will be having less misconfigurations, and there will be less mistakes in the configuration. So accuracy improvement will be there, and also increased efficiency. So increased efficiency meaning like it will help us to perform tasks faster than the normal manual process. It will enable us to complete tasks much faster way compared to the we doing it manually. So efficiency will be increased, and also the time will be reduced that we discussed in the accuracy improvement, and also it will automatically reduce the main efforts that we can put on a specific configuration. Instead of you copy pasting the same thing again and again, if you do it once, it will do it for you, right? So that way it will increase the efficiency. Next thing is agility improvement. It will help us to quickly respond to any network conditions. For example, if a let's say specific interface went down, so instead of you manually logging in, if you put in a poll on that, if that interface go down, you should automatically shift the traffic so that you will move through the traffic to a different route, right? So instead of you manually going there and changing the routes, your automation script can do that, right? So for example, if there is a problem with the errors, right? If you put a condition that if this interface has errors and we have to fail over the traffic, so you can put a condition based on that condition, a script will automatically run on the network, right? So you can create like if and else conditions, and you can create loops. You can write loops, and then you can take some predictive actions. When something happens, you will do this. Something happens, you will do this. So you'll create conditions in it, so that you can create a proper workflow. The next thing is scalability enhancement. We already discussed about this. This will make us to have manage like big networks, like large networks, where we can manage them with ease. We don't have to worry about thinking like, hey, I need to deploy 100 switches or 200 of them. I have to sit like 4 or 5 days continuously on the network to configure all of them. If you have a good workflow of automation, it can do the base level configuration across all the devices within hours. It doesn't even take an hour, right? Less than an hour, you can complete them. If you're doing manually, it would take 3 or 4 manual engineers, and then you have to do 10 hours a day, right? That can be reduced by doing the automation. And we also discussed about having inventory management. When you have multiple devices and you wanted to keep track of all the devices, make sure that they are all reachable, they all have NS lookup or how can be pingable. You can create inventory and you can run scripts among them. That way you can use automation. That will be the major ones at the impact of automation on the network management or network devices. Any questions?
Keeping track in the sense, keeping track of the logging, sir?
No, keeping the track of serial numbers. For example, you want to know what is your inventory, how many devices you host. So you can run a script that will log into each device in the network. For example, if you wanted to run a script on 10/8 network, so you will do an SS scanning with automation, right? It will scan all the devices in the network and then get responses, and you get an IP addresses for each response. You can log into each device with the automation script by parsing the data, and it will log into the device and then get you the serial number. So instead of you logging manually and getting the serial number, the automation script will do it for you.
Okay, sir. Thank you.
Okay.
Sir, I had a question too.
Okay.
Sir, in real time, how much time do you spend on, for example, an Ansible box? How much of scripting do you know in Ansible, or how much time do you spend there as a network engineer?
Personally talking about me, or you're asking about a network engineer?
Just in general, sir.
It really depends on what is your role, right? If you're a network DevOps engineer, you might be spending more time on Ansible or Python, or working on what are the protocol that you're using out there. It really depends. But if you're a network engineer, pure network engineer, and you're doing baby steps in the automation, I would say once a week or once a month, depends on the use case, right? 70% of the companies still use automation only for doing the upgrades, only for doing the version control, meaning like taking the backup of the configuration. 30% of the companies are using automations only for doing bulk updates. But if you're using a process workflow, meaning like when a request comes in, it will be automated all the way to the point of request completed. Very few companies does that. Still some manual interventions are there because it is tough to automate everything. Every workflow cannot be automated. It is tough. But if we have the chance, it is good to do the automation. But me personally, I have done multiple projects, right? In one project, I have done more automation. In one project, I don't do automation at all. So it really depends on what project we are talking about. But as a network engineer, if you are purely a network engineer who are working in routing, switching, a little bit of firewalls, you might not do that much automation. You might do a little bit of cloud, and the cloud automation is based on the Terraform. Again, it's not Python or Ansible. They use Terraform. It's a workflow there, right? So every role differs in terms of automation. Some people, they don't even touch automation because their networks are so small, they don't need automation at all. They can manually manage it, and they can work on regular routing, switching, regular interface creation and stuff like that. But because automation is so booming, people are learning automation. But in reality, if you have 10 network engineers in a company, you will have one automation engineer. The ratio is 10:1.
Got it, sir. And what sort of tools do you use? Is it what sort of tool is used more commonly? Is it Cisco, the Juniper one, or Ansible Towers only?
Well, Ansible Tower is only one use case, right? It's not like used everywhere. Ansible Tower is like product proprietary that is used by Red Hat. All the companies doesn't use Ansible Tower. It is very, very rare. If you see 20 companies, only 2 of them use Ansible. I feel many people use their own workflows inside their network. Some people may use Jenkins, right? Some people may use directly Python that is written there, which is integrated with their workflow automation. I have seen people using DCNM, ACI, which will inbuilt do the SDK, software defined kits that will be built automatically on them. I have seen people directly doing Linux kind of stuff where they use Perl as their code to automate. I have seen people using directly like template based, like Jinja template that is already written. They use the Jinja template. They don't even touch Ansible script. They just update the Jinja template and then they can push it. So again, it is not something that is used everywhere, but Ansible is something that is booming because you don't have to deal much with into the coding. It is very simple. The format that Ansible uses, it's like key value pair, right? It's very simple to understand. So people, network engineers are moving towards it. But the boom started only in 2019 or so. Before 2018, 2017, it's very handful. You don't even see, like out of 100, you will see only four or five companies using automation much. Specifically like product-based companies like FANG, right? But if you go into a state client or if you go into a healthcare, they are so old, they don't even touch automation yet.
Okay, got it, sir. Thank you.
Yeah, no problem. It is good to learn automation, but if you don't know networking, there is no point of automating networking, right? You have to know networking to automate something out of it. If you are just a coder, if you know DevOps, there is not much that you can do because you have to understand the few concepts in networking before you automate them. So I think there is a misconcept that people are learning automation these days and being a network DevOps engineer, they don't know much about networking. I have seen people who are working in Amazon who know automation well. They are called as network DevOps engineers, but they don't know networking at all much. So they come back again, they learn basics to understand what they're automating. But it's an off topic.
Yes.
Okay, so let's go to the next one. That is using a controller, right? So traditionally, when we use old networks, they are like standalone networks. Like we have seen into the different types of networks, like core distribution access layer. We have talked about collapsed core, or we talked about spine and leaf architecture, right? So these are individually managed devices. Like you have to log into each device, and you can run the configuration on them, right? But it is not a controller-based concept. But this is something that is used in wireless way before, because when you have multiple access points and you can manage them, all of them from a single controller. You can push the configuration, you can upgrade them, you can downgrade them, you can shut them off. So you have a controller configuration that can be pushed to all the devices underneath it. Similar concept works in the automation and programmability, where we can use a centralized controller and we can manage the configuration from it there. So the advantage is you don't have to log into each device manually. Once you log into the controller, you can push the configuration to the devices. So that's the main use case, where you have a centralized view of all of your devices. It's just like having a database, right? You can have full view of your network. What is the health of the network? What is going on in the network? So you can have a centralized monitoring tool. So with the controller-based configuration, we can make some management actions like building configurations, changing routing, putting security patches, upgrades we can do from the controller. So that is important, because when you're working in a data center like let's say Citibank, they will have thousands of switches, and you don't want to manually configure them, or you don't want to manually push the configuration. Well, it is doable, but still it is not a good way, because we have other things that we can make it improve, right? So that's why we have centralized controllers, where we can manage multiple network devices from a single point of contact. So again, what are the main advantages, right? One is management. So management is basically, that you already know that instead of we managing it independently, like I mentioned, we will use a controller, and all the network devices will be managed by the controller. So it's the ease of management will be faster and also easy to communicate between the devices. That is one thing. Another one is scalability, right? So when you do one configuration at a time, let's say you are in a change window and you wanted to push like a VLAN configuration to 25 devices. So instead of you log into each device and configure VLAN and then you put on the interface, you can create a script and you can, in a single go, you can push the same VLAN to all the switches, right? So that way, we are increasing the scale here. We are doing the scalable solution here. Instead of we manually going and doing the configuration on each device. So a controller can help us to scale the networks. Next thing is agility. As we talked about agility, we can create conditions. If there is a change in the network, to identify what changed, we can take a selective control action on top of that. For example, let's say there is a route that is flapping, okay, because of the high CPU. So we can monitor that device. We can check the CPU by doing an probe or polling on that device. And if that CPU is getting like 90%, we'll automatically inject a null route into the device because it will drop all the packets, right? So we can make it like those kind of conditions that is already written. If this happens, take this action. So we can define that well processed course of actions that we can define that will help us to do with the controller. So on the controller, something called templates are there. So these templates are something that can be defined on the controller, and from there you can push the configuration to the devices by adjusting the templates. For example, if you want to rate limit the traffic on the interface, that need to be done on all of your interfaces, right? So you will create a template. Under the template, you will create your rate limiting configuration, and you will apply that rate limiting configuration to all the interface from a single go perspective. So that's how we can do it from a controller, make it faster, make it scalable and agile. Agility is there, sorry, not agile. Okay. And the last thing, the centralized control is the visibility. So you can review health of all the devices. You can review existing connections like maps. You can review utilization reports. You can review high memory. You can review critical logs. So this management will be faster from the controller perspective. So when there is an issue, instead of you log into each device in the network path, you can have the controller login, and from there you can have a full view of health of your network, right? So that is a good use case where you can get visibility into your network with better way than regular manual process. So you can also have so overall, what I was trying to say is with the centralized controller, you can have many advantages. Like I mentioned, like you can validate the scalability, you can increase the network visibility into your network, and then you can easily manage them. If there's an issue, you would easily know, and you can faster react and reduce the downtime for the user. So that will be the major difference having a controller versus managing them traditionally, manually adjusting them. Any questions there? No questions? Okay. We'll talk about. We talked about controller-based architecture, right? Where we will use a centralized controller to manage all of our networks, where it will provide the unified view, like a single point of view for all of the networks, and you can have a centralized controller. So there is another architecture called software-defined architecture. So let's talk about that. So software-defined architecture is something that needs better understanding of control plane and the data plane. Can anyone tell me, let's say, Sudhir, can you tell me the difference between control plane and data plane?
Control plane is like the body of the no, I couldn't remember, sir.
It's like a brain of the system. And
Yeah,
data
brain of the
is,
system.
Yeah, control plane will make all the decisions related to the device. Based on its orders, the data plane will forward the packet. It is like the body. Control plane is like the brain, right? So in the software-defined architecture, we can have a separation of the control plane to the data plane, meaning, let's say, this is a device, okay? This device will have CPU, ports. Let's say there is a packet that comes into the switch. The CPU will check its routing table. And based on the routing table, it will validate what will be the outgoing port. For example, the port is 1. So the packet comes in at 2. The CPU checked and it will say that go to the port 1. So port 1, the data plane of the ports will automatically forward the packets to the port 1. Here the data plane is just doing the forwarding of the traffic, right? So this is a regular architecture, right? But instead of having the CPU decisions on the router or the switch itself, right? We can move the CPU to elsewhere. For example, you have a centralized controller. So when the packet comes in, the controller will take the routing decision because the CPU is there. It will tell the action to route it via port 1. So instead of managing each device control plane on a single device, the centralized control plane will manage hundreds of devices. So when the packet comes in on a ASIC on a specific device, we'll check with the centralized control plane, and that will give the action to route to which packet it can send it to. So what it can do, guys, it will have less actions need to be done at the switch level, but the controller will do all the necessary calculations, which port need to be gone, which port need to be used to go the traffic out. So by using the centralized controller, it is easy to manage many devices because the control plane lives in a centralized place than having it on each device. That way, it will have full view of the network. It can manage more networks easily. For example, if your control plane go down, for example, if the CPU on the router go down, it will cause the entire switch to go down, right? But in this case, even though if your control plane go down, because it is sitting here, the ongoing traffic will still flow because the decision is already made and sent to the switch. But the new traffic, whatever comes in, like for new routing decisions, that traffic will still fail because the control plane failed. But the ongoing traffic, which is routing decision is already made and sent it to this guy, the traffic will still continue to flow. That is also one of the use cases that is advantageous in the control plane versus data plane. Any questions there?
Sir, what happens if the centralized controller itself fails?
That's why you will manage copies of it. You will have 3 of them in a cluster. If one go down, you have 2 more. Because you are managing your network with centralized controller, you will have 3 of them. If one go down, you have copies on 2 other of them. So the chance of going all the 3 is very, very, very rare, right?
Yes.
Yeah, that's why we have copies. If you take Epic will have 3 controllers in the cluster. Do you guys know what is Epic? Okay, Epic
No.
is an application policy infrastructure controller. This is Cisco based. So this is the Cisco version of managing from a centralized controller or having SDN, right? I mean, software different architecture. So it will have 3 members in the cluster. It will maintain all of them in the single cluster. Similarly, if you talk about Arista is called CV3, Cloud Vision Portal. If you talk about Juniper has Juniper 1. What else? What are vendors we have? If you talk about Aruba Central. So these are all different vendor names, right? But the action is same. They have centralized controller with 3 of the members in the cluster which are maintaining the control plane on it, right? So now you understand the concept, okay? That is about the software different architecture where we have the separation of control plane versus data plane, and this separation will manage the configuration easily, and also it will instead of we making the routing decisions on each device, the controller will tell how we can route the packets to, and it will maintain the whole routing table database on each device.
One small doubt. This is my personal doubt. By anywhere, Aruba's mobility master is related to this particular Aruba Central?
That's a different concept, whole different concept. Let's talk a little bit on that. So if you talk about Aruba mobility master, let's say you have a mobility group. Okay, let's talk about what is mobility group, right? Let's say you're sitting in a building, you are connected to an access point, and let's say you're roaming. So in the wireless, when you roam between one access point to a different access point, there's a chance of losing your authentication and IP address, right? So for example, if I'm sitting in a building in the floor 1, I'm sitting in the building floor 1. And let's say I move to floor 2. So because I moved from floor 1 to floor 2, the access point will not do the handoff between the floor 1 and floor 2, right? So that's why we will create a mobility master or mobility group, and we'll put a controller to manage all of them. To hand off this authentication to other controller, the mobility master will hand off that access point information between them. But the mobility master controller is when you have a remote location, you will have an anchor controller here.
Yeah.
The anchor controller will be managed by the master controller.
Right.
So that is something like way out of this league, but somewhat similar in terms of managing the access points. Still, it is a controller,
Okay.
but the way it operates is different than what we are talking.
Oh, okay. Okay. Yeah, got it.
Yeah, that is out of the scope of Cisco. That is something that is a whole different vendor, and the concept is whole different. They also use their own protocols to do this, right?
Yes.
But
Yes.
anyways.
Right.
Yeah. Okay.
Thank you.
No problem. That's fine. Okay. Where are we? Okay. Yeah. So we talked about software defined architecture, right? So where we talked about controlling the data plane versus the separation of control plane versus the data plane. So we talked about that. We have to talk about the underlay architecture and overlay architecture now. So underlay and overlay, you guys already know about this concept because I spoke with you guys already about this. Can someone explain me the concept of underlay versus overlay? Shiva, you want to try that?
I'm not sure what it is.
Okay, anyone? We discussed this many times, guys. Underlay, overlay.
Is underlay physical and overlay virtual?
Can you elaborate?
Actually, I was not here in the earlier classes. I watched a YouTube video.
Okay.
Yeah.
That's fine.
Underlay
It is
will
kind
be
of right. Yes.
physical connections, and overlay will be virtual connections. Physical connections meaning routers, switches, your Ethernet ports and stuff like that, and overlay will be virtual connections, like logical networks that we build on top of it, like your VLANs and stuff like that, I guess.
No. You are 70% correct, but when you said the VLAN, the concept is wrong.
Oh, okay, sorry.
So
What about VPNs? Would that be more specific to that?
yeah, VPN is correct. So when you build a VPN over the physical infrastructure, that is an overlay. So having a VPN is overlay, and having that reachability is underlay. I think we talked about this multiple times when we talked about VPN, and also we talked about when we are doing what topic we talked about this. We talked about building a road between the devices will be underlay and the data passing will be overlay, right? When you have two sites and we connect them using a road, that is the underlay connection between them. So the road that you see between the sites is an underlay, but the actual cars passing on that road will be the overlay, right? So we discussed this kind of analogy previously. So let's talk about that again. So let's say you have a network, right? Let's talk about having two routers. And let's say these are geographically separated. Let's say this one is in, let's say this is in Seattle. And let's say this is in Austin. And you having a road between these two locations, right? Like a roadway that is having a connectivity between them. That is the underlay. This can be a physical connectivity. But the actual data, for example, if you have a CPU, I mean, a device behind this router, and you have a device behind this router, and this device wants to talk to this device. When the data of this device actually passing over that router, this data passing is called overlay. So we are using some sort of underlay connection to have that overlay. Why do we really need this, guys? Why don't we use just the underlay for this PCs to talk? It could be because of the security. We wanted to use overlay. We don't want device in the path to see what it is, right? We don't want the device in the path For example, this is Chicago, this is maybe New Mexico or Arkansas, right? So we don't want these devices to know what the actual data is. Then we'll use an overlay which will be encrypted. The other device doesn't know what the data is actually passing because the payload is encrypted. So that is one use case. Another use cases is to have the logical building, right? So even though this device is separated from this device, from a logic perspective, when you do the show IP route, it will automatically show the next hop as this router, even though they are miles away, because the overlay routing will show the next hop as the Austin router. From a routing perspective, it is only one hop away. Is it making sense?
Yes, sir.
Okay. So underlay is that, overlay is that. So underlay will be a physical network over the physical infrastructure that can provide the connectivity between all of those, right? So that is underlay, and the overlay will be a network that is running top of the physical underlying architecture, like your VPN, like your VXLAN, like your OTV, or like SSL VPN, like remote SSL VPNs, that like we talked about, sitting in a coffee shop like a Starbucks and connecting to your network with SSL VPN connection, right? That is an overlay. And there are many more, like having a proxy connection. Different use cases are there. Again, I don't want to go deeper on that. Just keep reminding the concept of underlay and overlay. Okay. Next thing is fabric architecture. Let's talk about that. So fabric architecture means like it is like a network design that is like highly scalable and flexible, right? For example, when we talked about the initial classes, we talked about spine and leaf architecture, because it is easily scalable between the east-west traffic, right? If a server wants to talk to other server in the same VLAN, instead of going all the way to the core, we locally switch between them using the east-west traffic communication, right? So that kind of workflow is called fabric. A fabric is nothing but having the highly scalable network like spine and leaf architecture. We call it as fabric. I think this is our second class or third class where we talked about network topologies, where we talked about spine and leaf architecture. We discussed about having an east-west communication faster than going all the way to the upstream device. Anyone remember that? Anyone? Do you guys know what is spine and leaf architecture is?
Yes, sir. Is it like having high bandwidth and low latency?
Yes, that is correct. We have high bandwidth and low latency, but that doesn't mean that it gets only that, right? For example, let's talk about that. I don't want to. This is something like a spine and leaf architecture, right? So for example, if you have a PC here and it wants to talk to PC here, So let's say the layer 3 is here. If they're in two different VLANs, this is VLAN 1, this is VLAN 2. To communicate between these VLAN and this VLAN, it has to go all the way to the core and then comes back up, and this reaches to VLAN 2, right? So that might cause some more traffic usage than it need. So instead we can build a tunnel between these two. For example, we can build a tunnel between these two, and we can make them communicate logically over this physical link. So the connection of this is called underlay, and this tunnel is called overlay between these two switches. Right? We can do that. This whole concept is called fabric. There are a lot of things we can achieve. We can achieve microsegmentation. We can achieve zero trust. We can achieve, as you said, higher speeds, higher bandwidths, slower speeds. We can achieve that, and we can also achieve something called ease of deploying the configuration, because we can manage all of them with a centralized controller called Epic. And we can build templates to push the configuration to all these devices. We can manage them because the control plane lives on the Epic. These are all just doing the data plane forwarding. This is all part of the CCNP data center, guys. CCNP and core or CCI data center concept. It is not a network CCNA concept. But keep in mind that fabric is nothing but having a spine and leaf architecture, which will have the underlay and overlay. It can be deploying faster. It will make things faster for you. But guys, please go through the old recordings. I don't know, many of these guys are new, right? I don't see people who joined in my first classes. There are few like Maunika, I see Hari. There are a few people are there, but a lot of these names are new, who did not join from the first classes. So please go through those class recordings. If you don't have that recording, go through the group. The group will have all the recordings. If you are someone new to the group, there is an spreadsheet in the group that will have the tab which will have all the recordings. I don't know where it is, but I have to search for it. I did not get the time to search last time, but again, I'll check, make sure that it is posted again today or tomorrow on the recordings. Go through them, make sure that you understand the basics at least. Okay. Let's see, what's the time? Okay, yeah, let's cover the last topic in this last subsection on this, that is northbound and southbound APIs. And we'll conclude today's class. Northbound and southbound APIs are used to describe the interface between different components, right? Well, northbound APIs can connect the controller to the management systems. It can make an API call. Well, let's talk about the API call first. Anyone can tell me what is an API call? Application, programming, interface. Meaning like you are running a software, like you have a box, you're running a software on this, and you are making a call to another device, and you can change the configuration on this box. For example, if you want to do like a interface shutdown, so instead of logging into this device and then shutting down an interface, we can run the script on this device, and then we can shut down the interface on this device. So we are having a centralized software where we can manage all of these devices. So that is called an API call. So from this device, you are making a call to the actual network devices or any other device, and you can make changes on that system. So that is called an application programming interface, where you can use an API call to change something on the end host or the network device. So there are two types of APIs: northbound API, southbound API. Northbound API are the APIs where you have the controller. For example, we talked about EPIC controllers now, Cisco based, right? From this controller, if you are making a call to the higher management systems, okay? To the software. So from the EPIC, if you are making a call to the software, for example, the well-known ones are like Postman. Postman is a software. So if you are making a call from your EPIC controller to the Postman, that is called a northbound API because it is north to the system. Northbound API. Okay. If you are making a call from the EPIC controller to the actual network device, for example, if your EPIC is there, and if you're making a call to the actual device, like your leaf and spine switches, right? So that is a southbound API. So think about like this. From your EPIC controller, if you are making a configuration change on the device, like shutdown interface, no shut, that is a southbound API. If you are making a call to your software from your EPIC controller, that is a northbound API. For example, a good use case for this workflow is, let me give you a real-time example, okay? Let me talk about this. Okay, let's say there is a movie theater, okay? And there is a software to book the movie tickets. For example, Regal movies, okay? There is a software, Regal movie software is there. That is, it's an application in your app, okay? It's an application in your phone, okay? And there is a person who is sitting in the counter before the theater, okay? He is the person who is giving your tickets. And there is a person who is at the inside the theater helping you to check your seat, okay? Or he's giving you popcorn to your seat, right? So you making a call, you as a person opening the app and talking to the theater, like booking a ticket inside the theater, this call will be southbound. And this software, whatever they host, getting the ticket back to you is northbound. Similarly, from the theater guy, giving you a ticket and sending you to the actual theater will be southbound. And if this person sending you back to this person will be northbound. So think about the workflow. When the downside device is talking to upside device, that will be northbound. If the topwise device talking to the downside will be the southbound API. South is always going down, north is going always up. It's like communication, how they are making between the devices. So if you have a software like a Postman, if that is talking to a controller, EPIC controller, that will be southbound. If your EPIC controller talking to a network device, that will be southbound because the EPIC controller will have the controller plane that is talking to something in the data plane, that will be a southbound. So that's the workflow, guys. Any questions? No questions? Okay. That's all for today in our class. Let's do a quick round of validation about what we discussed. We discussed about impact of automation in the networking. We discussed about having a streamlined process, accuracy improvement, efficiency increase, improvement in the agility, and also we discussed about scalability of the networks. We discussed about having a centralized controller to manage everything. We discussed about how to manage many devices from a centralized control plane. What are the advantages of it, like having good management, having highly scalable network, having more network visibility, all of that, and we discussed about, different architectures like centralized control architecture. We discussed about software-defined architecture. We discussed about fabric architecture. Let's see. Hari Prasad, can you tell me what is a software-defined architecture is? Sriram, can you try? Can you guys hear me? Hello?
Yes, sir, we can hear you.
Okay, can anyone explain me what is a software-defined architecture is?
So software-defined architecture is like a control plane and data plane as a centralized control who this controls the ports. If CPU is coming, it's like okay.
Yeah, software-defined architecture is like having separation of control plane and data plane, where you will have forwarding actions done by the control plane that will be implemented by the data plane. It will help us to easily manage and configure the network through software rather than manual configuration, right? You can have like an Epic controller or CVP Cloud Vision Portal at the Arista level, right? Different vendor use it differently. So we can have a centralized controller to manage all of them. Okay. Okay, Ranga, can you tell me what is an fabric architecture is?
Fabric architecture is nothing but having a lot of connections. It is same. It is same as I don't remember. Like if something goes wrong, we have like a lot of networks so that it will be easy for the network.
Yeah, it is highly scalable, and it can be interconnected in way that will allow multiple connections. If one go down, it will have another other link. At the same time, it can do something like an underlay overlay connections, so that east-west traffic can be moved faster than the regular networks, because your layer 3 will be splitted, or you can have an overlay, so it will be logically connected between the hops, right? So that is one thing. Yeah, and then we also discussed about separation of control plane and data plane, and what are the advantages of it. And next we discussed about the APIs, like making an API call. We discussed about northbound and southbound APIs. So Shiva, can you tell me what is the difference between northbound and southbound API?
Yeah. So firstly, API is a centralized software where we can change anything required on a network device without logging into it. So a northbound API would be making this particular call through the software at the same time while making the same call through network devices, it would be southbound.
Yeah, so basically it's a workflow, right? When a downstream device talks to upstream device, that will be a northbound. When the upstream device talking to a downstream device, that is a southbound API call. It's basically without logging to the device, we can make the actions from a third-party software or a third-party device where we can manage other configuration pieces. Yeah, that is correct. Thank you. So that's what we discussed today, guys. In CCNA level, we don't do real automation. We don't create scripts. We don't do purely on the anything related to the actual configuration, right? We don't log into the Python, or we don't do log into Ansible, but we just understand the concept so that we can understand at an associate level. So in this section, we purely talk about the concepts and the terminologies only. you will not be asked to do any automation in the exam, or in your real time. If you go with a network engineer, you have to understand what tools they are using and then get trained on them. But at the CCNA level, there are no tools that needed to be learned. But it really depends on what job role you will be attending to, and you may need a little bit more training on that specific tool. Okay, I'll stop the recording here and I'll leave a couple of minutes to you guys, ask you guys if you have any questions. So let me stop the recording.